Up next, our special guest is Vidya Rajagopalan. She's the Senior Vice President of Electrical Hardware at Rivian, and we'll be discussing all kinds of fascinating topics, why they're developing their own computer chips, how much tech is too much tech, and we'll find out what Rivian's plans are for autonomous driving. So stick around for all that and a whole lot more right here on GreenCars, the podcast. Well, if you want to learn more about sustainable transportation, you are in the right place because that is exactly what we cover here at GreenCars, the podcast. I am automotive journalist Craig Cole, and I'm joined by Sam Abuelsamid. He's a trained engineer, but he's also the vice president of market research at telemetry, and he's my co-host here on the show. Sam, what have you been up to these days?
Well, last week I visited a new EV development center in California that you'll have to check out greencars.com to read all about that.
Can you talk about it yet, or is it embargoed?
No, it's live. I went to Ford's Skunk Works, where they're developing their $30,000 electric pickup truck.
Nice.
And a whole lot more.
I'm very excited about that vehicle. I hope it pans out because they've had some, let's just say, bumps in the road lately with their EVs.
Yeah, well, at least I can say this much. It is a truck-shaped truck. So
well, I would hope so.
If you want something truck-shaped in your pickup trucks, Ford's got you covered on this one.
Well, that's good to know. But as I mentioned at the top of the show, we've got Vidya Rajagopalan, again, Vice President of Electrical Hardware at Rivian. And that's a very broad topic, but what are you hoping to learn today, Sam?
I want to dive a little bit more into some of the things they're doing with the electrical and electronic architecture of their vehicles. They've really advanced the design of those parts of the vehicle. So that's the wiring, the computers, and everything, in order to make their vehicles more software defined, so they can add new capabilities. So I want to learn more about that, learn about what they're doing, and talk a little bit. Hopefully, learn a little bit more about why they're developing their own chips.
That's a big one. They're very much taking the Apple approach, it seems, which has some huge benefits, of course.
It does, but it also has challenges, and Apple sells hundreds of millions of iPhones every year and iPads and Macs that all use those chips. Rivian's volumes, a little bit less than that.
I would imagine a little bit less than millions and millions.
I mean, even if you take the entire global auto industry, it's less than the number of iPhones that Apple sells every year.
Exactly. So we'll get to all that and a whole lot more once we welcome Vidya to the show. But really quick, for help finding your next ride, make sure you visit greencars.com, where we have expert reviews, a helpful buyer's guide, there's an EV matchmaker, and a whole lot more. Again, that's greencars.com, your hub for sustainable motoring. Starting an automaker has never been easy, and I think it's especially hard these days with all of the rules and regulations. But I'll tell you, I think Rivian in the world of startup companies is doing a lot better than some of the other ones out there. They've got some really exciting products with their R1T pickup truck, the R1S 7-seat SUV, and then they've got the new R2 and R3 utility vehicles that look fantastic. And Vidya Rajagopalan has played a huge role in the development of these models and a lot more. And Vidya, welcome to the show today.
Thank you. Thank you for having me.
Yes, it's a pleasure. So why don't you tell us a little bit about what you've been doing at Rivian?
So I am the vice president of electrical hardware. So my teams are basically responsible for building all things electrical. So that may be the autonomy computer, or it may be the cameras, the displays, the audio, and then all the way down to the power conversion. So the DC-DC, DC to AC, all our power conversion units, electrical inverters, motors, anything that involves the transport of electrons is generally in my team, including things like the wire harness.
So, Vidya, one of the things that has been a key for Rivian is that it is a vehicle that I think right from the beginning has been designed as a software-defined vehicle. So in order for that to happen, you need a specific kind of electrical architecture. So can you talk a little bit about how the the architecture of Rivian vehicles has evolved from the original R1 to the second generation and now into the R2. What has changed, and what are you doing differently, and how is it going to talk a little bit about some of the things, how it's going to be evolving further over the next couple of years?
Absolutely. So to have what is called a software-defined vehicle, you really have to really control all the software that runs on the vehicle. And to do that, you really need to control the hardware. So one of the things we at Rivian have always done is believe strongly in vertical integration. So even as a startup, when we first started our company, we built all the controllers, the ECUs or the electronic control units, we built them in-house. And our first generation R1S adopted what's called a domain controller philosophy. So we didn't jump straight to the most complex implementation. A domain controller fundamentally has an ECU per function. So we had controls for body controls, vehicles for controllers for dynamics, controls for infotainment. Everything was separate, a separate controller for thermal management. And that was a great way for our teams to get started and to, get working very quickly. So the thermal team worked on the thermal controller. They could just all work on it and get off the ground very quickly. So we evolved from that. That was R1 Gen 1 to R1 Gen 2 architecture. We moved to something called a zonal architecture. And what the zonal architecture aims to do is really consolidate a number of these ECUs. The challenge with the old way of doing electronic design for vehicles is that you result in a proliferation of ECUs, a lot of controllers. In fact, if you go way back and don't look at the domain controllers in our R1 Gen 1, if you look at really traditional OEMs, they tend to have a lot of little boxes for every function. Maybe one box for the wiper, one box for the seats, one box for something else. What we did is consolidate in our first gen to these functional or domain-based controllers. But in our R1 Gen 2, we went to building what's called a zonal architecture, where really we went to a geography-based controller. So we had a controller in the left side of the front left of the vehicle that controlled all functions for the left-hand side, something on the front right that controls everything on the front right, and then one at the back that controlled stuff at the back. And just one at the back instead of two in the front is because there's far fewer functions at the back. Your vehicle tends to be dominated with functions at the front. And so the way I liken this is my favorite example is think of it as post offices. You tend to have post offices by a zip code, and you think of the controller in a certain area servicing that zip code. And it's why does that matter? It's a more efficient way to handle wiring. Because if you think of a lighting controller, if you had a traditional lighting controller, that controller has wire, you have lights all around the vehicle. So you'll have wires from wherever that controller is sitting to all around the vehicle, which is not the most efficient way. And the wiring in a car actually tends to get pretty heavy and long and ends up costing cost and mass. So what we migrated from our R1 Gen 1, which is a domain-based architecture, zonal architecture, and our R1 Gen 2. In doing that, we actually saved 1.6 miles of wiring and 44 pounds of wire weight in that first iteration. Right?
And copper is not cheap either for wiring.
That is not cheap at all. It's not cheap, but it's also mass, which then means your vehicle needs less energy to be propelled forward. And then we built our R2, which we just went into production recently. And what even though that continues to be a zonal architecture, we really improved on that design further. And actually, we're saving a little over, 2.3 miles of wiring yet again by iterating on the design and improving, and saving yet another 44 pounds of mass on the wire. So even though it's still zonal, we had room for improvement. The R2 is a slightly smaller vehicle, so some of it comes from that, but a lot more of that really comes from the design. So fundamentally, taking a step back, we really have the strong belief in vertical integration, hardware, software, co-development, owning the whole stack, and really looking at the entire design as a clean sheet of paper and architecting it thoughtfully from the get-go, as opposed to bolting on new controllers as and when you sort of said you want to add a function. And when we do that, we can have the most simple, most elegant design. We really architect the whole thing as a single computer system. as opposed to, different functions that get bolted on.
Mm. So, just really quick for viewers or listeners that may not know, what is a software-defined vehicle?
So a software-defined vehicle is really one where the features are implemented by software at a higher level, and it's not a one-time thing. The software, it's really much like your handheld smartphone where features are updated. You get monthly over-the-air updates, and features evolve over time, and they get
Mm.
better over time. And that's why, you traditionally electronics in the old days would depreciate after you got it. Well, that's still true of vehicles, but if you think about it, the feature capability of modern software-defined vehicles actually gets better with time, which is different from what you're traditionally used to.
Mm-hmm.
Yeah, I'm an engineer by training, and I
Mm.
worked in electronic control safety systems for 17 years, and I'm very familiar with the traditional distributed architecture that you talked about, where every function has its own ECU around the vehicle. And in those days, there was no mechanism to update most of the software. We had to design everything so that it was done from the time we started building the vehicle, and that's what stayed in the vehicle until it reached the end of its life. And
Mhm.
now vehicles can evolve over time. So in order for that to happen, though, you need a couple of things. Obviously, you need a lot more compute power than we had in the old days,
Mhm.
and you need a software platform that's designed to allow for that updating. So, how much compute do you really need in a modern vehicle to enable it to be an SDV, a software defined vehicle?
So I think there's really two kinds of compute if you look at it in a software-defined vehicle or just about any vehicle. There are these real-time processors that are used for control. They're microcontrollers. They control like a lot of functions like body dynamics, all of that. And then you have perhaps an infotainment processor that's handling all of the display and other functions. And then you have something for autonomy. That's sort of your broad three classes. And the way we design them is really when we launch the vehicle, we design with headroom. So you design it so you have enough compute headroom available in all of them so that over the lifetime you can add more functions to it. And so computers really become cheap if you think about it. What you can do on your handheld phone today would have been a desktop computer at some time. So computers, honestly, compute performance is not a bottleneck. It's more planning for it from the get-go, right? You can get microcontrollers for, sub $10 that you can put a lot of compute in.
Is there ever a point where modern vehicles have too much technology? Are drivers asking for all of these features? Or is it something like if you build it, they will come, if you offer it, they will buy it? What's your take on that?
Yeah. Well, I think the technology should be such that it's not really visible.
Mm,
So I think if you
yeah.
have a lot of technology and you have a lot of buttons that everybody needs to go press, then it's not ideal. But I was just driving my R2 yesterday and 2 days ago, and I was marveling at how much better it is compared to our previous generations, how much better we're getting at software from the get-go. Is that door handles? They present themselves when I am literally 3 inches from the door, not too early, not too late. And when it does that, it just feels right. You arrive at the door handle opens just a second before you get there. It's very intuitive. You didn't need to do anything. So that's a kind of technology that the user doesn't need to know anything about. And I think that's important is that there can be a lot of technology, but it needs to be hidden in a way that the user doesn't need to know figure out how to program it to use it
Hmm.
and has to just be intuitive. So yes, the user not saying give me technology, though I think there are a lot of technology people um who love vehicles for the technology in it and are attracted
Yeah,
by it.
yeah.
But I think what the user is saying, make things intuitive, make things easy to use, and allow me to do things in the car that I could not do before.
Hmm.
Right.
I
And
guess.
then, yeah.
Oh, go ahead.
Mhm. No, go ahead. Mhm.
I was just going to say, following up on that a little bit, um, you know, things like self-presenting door handles, retractable door handles. Some might argue that may, even though it's intuitive that it just pops out at just the right time, traditional mechanical door handles are always just there as well.
Yeah.
And in fact, in China, they're currently changing the regulations to ban those types of door handles.
Mhm.
And that's one where I think, to Craig's point, is maybe that perhaps going a little bit further than we need to with technology, adding technology where it doesn't necessarily actually provide a benefit to people.
I disagree. I think I go back to the old days when, it was rotary windows. I remember when, you used to have to crank a little rotary thing to actually get your window up and down. And when they first had the power door windows, I thought, oh, why would people be so lazy? Why would they ever need something like that, right? And it's not something you question. So today, I don't think anybody wants to go back to that old rotary system anymore. So
Well, there is one company that wants to, but
yeah.
we're not talking about them today.
Yeah.
Yeah.
So I think, the door example is different. I think you have to have a way to make sure it's secure and safe. So you have a way to, you have a manual override whenever you need one. And that's important. And, you take that specific example maybe and say, what is a problem, of concern? You want to make sure it's safe and you have manual options. But for a lot of the, things that you can do in vehicles today, there is just the magnitude of things you can do today. I mean, you can be entertained sitting in the vehicle in many ways, right? You can browse the internet, you can watch videos, you can do things. You're waiting to pick up somebody in the car, right? And maybe you want to do something like that. Or, go back to thinking about something like Bluetooth and being able to speak through the car, right? And just go back to many years ago when that was not a capability. People would be, probably using holding a cell phone or whatever, or not doing it very safely. So I think there are a lot of features, and I don't think it's too much technology. I guess I would say I think, and it's also really a trade-off. I think for the people that don't like it, they don't use it, and that's they not everybody likes some aspects. Some people are enjoy some aspects more than the other, but you take all of it together. There are people who are big fans of certain features, right? And I think the superset of it all, generally some people use more features than the others. So
What are the biggest challenges when you add advanced new features to a vehicle? I would imagine it's the testing and the validation, so you know that it works and you know that it's safe. But is it coming up with these ideas? Is it writing the software code to enable them? What's your take?
I think interesting because we just now for the R2 introduced a new feature called the Halo wheel, which is a very different way of interacting with the vehicle, and it's really cool. And obviously one thing, a lot of it was when you introduce a new feature is developing it, testing it, making sure it works robustly in all circumstances. But the other part that is interesting is anticipating how people might use it because nobody's used it. And so really anticipating how a diverse set of people might use it is sometimes also that's almost a harder part because you don't really if it's not there out there yet, you don't really know how everybody's going to use it.
You never know
And so
what crazy
anticipating
things
that
people will do.
that's right. Anticipating that because just developing a feature, if you have a plan, you can go implement it and you can test it per that plan. But it's the stuff you didn't think about that usually gets you.
I was out at Rivian's Palo Alto Tech Center back in December when you made a big announcement that involved your next generation autonomy platform, which included developing your own in-house system on a chip, your own in-house chip, which is a big change for Rivian. You've used now through a couple of different generations of chips from different vendors, and now developing your own in-house chip. What is the advantage to Rivian of having your own custom processor that is essentially driving your vehicle now?
Absolutely. So we said it at that time, and it's the same answer today too. The three reasons: performance, velocity, and cost, right? And on top of that, I think we have to go back to remember we build our own software. And so we actually have really good understanding of the application end to end. So we're able to design a processor that really implements our stack really well. And that's a benefit you get because when you understand the application, you can design a processor that's really maximized or optimized towards that application. And so those performance benefits come from knowing what kind of models am I going to run? What is my processing pipeline looking like? How do I make this design really good on this application? Whereas if you do not design something, and I've spent a long career building silicon, you don't have the end application. You're designing to benchmarks. If you don't have it, you're designing to a lot of benchmarks or things, but you don't really know how the user uses it at the end, because that's often their secret sauce, and they don't want to tell you all that. We don't have those problems. We know it, and we can design to it. So that's one. And then we don't have anything superfluous. If I was building a general purpose chip for physical AI, I might throw in things for somebody who might be putting something else. So we don't necessarily have wasted silicon for stuff we don't need. And the silicon we have is really optimized, and we run our application on it, and we're able to optimize it for that. So that's the performance piece. The other part, as I said, is velocity. Is we get, the teams actually work hand in hand together, and we're able to pull in the hardware team, the software team. We're able to pull in probably 1 year of schedule because we're working. The software team has access to the design even before silicon's available. So we have hardware prototyping. The software team is starting to co-develop with us. So it's a shift left thing that happens is they start to develop earlier. We give them samples much earlier. Typically a chip company wouldn't give customers samples till they had vetted them and tested them. There's usually a delay before you get it. Here we're in-house, so there's a much lower bar. So we give samples earlier, so that means people get started on it earlier. And the other part is just when we run into issues, we iterate much faster. You have a problem, you walk across to the person who's working on the software, or the software person comes along, the hardware person, say, "Hey, I don't understand why it's doing this." And traditionally, with the merchant supplier, you file a case in a portal, somebody gets back to you, goes back and forth. So all that friction is reduced, and you can iterate much faster, which is why companies that vertically integrate are able to get really a very thoughtful and holistic product out sooner. That's the benefit you have. And then the final piece is cost, because we drive the chip, the IP is ours. Obviously, you spend some for development, and so it's not for free. But we did the analysis knowing our R2 volumes and going ahead, and we still came out ahead. And I think obviously it would not have made sense if we had volumes the scale of R1, but R2 we project to be a much higher volume vehicle. We still come out winning doing that.
Yeah, it certainly makes sense, from a lot of what you said in terms of really optimizing the chip. Things like, on the second generation R2, you're using the NVIDIA Orin chips. They're very powerful chips, but as you said, they have a lot of components, a lot of capabilities that maybe you don't necessarily need for your vehicles, and power consumption, especially in an EV, is really important, to bring down that power consumption, especially as you're adding new functionalities to it. So,
Exactly.
so what, I guess one question I have is, if you can answer this, is what sort of life cycle do you see for your chips, in terms of iterating, redesigning, how long do you expect a particular generation to be in production?
Right. I would say, somewhere in the, roughly saying 3-4 year time window. The staying in production would be how soon would we come up with something new? Roughly that 3-4 year window, I think, makes sense for us.
Okay.
And that's a good amount of time, to sort of recoup your investment, at the same time, get another generation out.
So you guys aren't using an Intel Celeron from the 1990s then? No. Something very much better than that. Which is why your infotainment systems perform so well. Like, you guys are doing a very good job with that. Which is a question that I had that sort of ties in with the computer chips, Sam, that you had brought up here. Many infotainment systems in vehicles, they perform quite poorly. That you will see stuttering and lagging. It's getting better now, but like, you go back 3 or 4 years, they weren't particularly good. They were nowhere near as good as like an iPhone. Why has it been so difficult for manufacturers to deliver that sort of seamless experience?
To be honest, I probably can't comment because we don't have that problem.
Yeah.
I think it has to do with more the mindset, that I can only speculate. But I think there are two reasons. I can talk about why we don't have that problem and why the iPhone probably doesn't have that
Yeah.
problem, is because two things. They're both vertically integrated products where the company owns the hardware and the software, and they own the whole thing,
Mm-hmm.
the whole shebang, right? And they own, and so you can really optimize it together. You have the teams. You can, it's what I talked about, the velocity piece that you get out of with vertical integration and the lack of friction, because you can just work very closely. Hardware and software teams can work very closely to optimize. The other part, and I think this is maybe coming, is a mindset, is a more technology mindset. And I think that's coming to automotive now, but it wasn't there before. Is really, if you treat that more as a computer and sort of look at it as computer technology as opposed to automotive, that's maybe the other shift, and that's happening. And that might be what you said, is you see it happening, but slowly.
Mm-hmm. Yeah, it's
But I think we don't
old-fashioned.
have that issue. Yeah.
Yeah, oh, definitely. It's old-fashioned manufacturing, old industrial revolution industry versus the latest and greatest computer chips. So a big contrast there.
Mhm.
So, continuing on the theme of vertical integration, again, another thing that was announced in December was move to developing your own in-house autonomy platform. You already have the universal hands-free now in the R1,
Right.
and you're moving towards eyes off and eventually brain off
Mhm.
level 4 type systems. And you've recently gotten an investment from Uber and others, and a commitment to use your vehicles. So how is that process working out? Or is that's all being developed internally by your teams at Rivian, right?
That's
And
right.
yeah, so tell us a little bit about what's happening with that to
Mhm.
the degree you can.
So yes, absolutely. We announced, it's all under the umbrella of what we call Autonomy Plus. I mean, our base vehicles will always have some basic autonomy features, but Autonomy Plus is a enhanced tier, and where I think you pay $49.99 a month, or you can buy outright today. Outright, buy it out for $2,500 a lifetime. And today you get two features we call universal hands-free, and you get lane change on command. So universal hands-free basically allows you to drive wherever there's a painted line or a dotted line. It will drive for you with your hands off. There are a few limitations today, like right now we don't handle rotaries or traffic lights, but in general beyond that, but those are all going to be addressed over time. And then lane change command is a feature where you sort of move the stock, like you're going to do a right turn, indicate that you're going to take a right turn. The vehicle will take a right turn at the right time for you. Similarly, same happens on the left. But maybe this is a great example to talk about software-defined vehicles. We always knew that autonomy was a key feature for vehicles going forward. So when we did the R1 Gen 2, we actually up-revved all our autonomy hardware in a huge way. So we updated all our sensors. We used to have two 1 megapixel cameras. We went up to 8 megapixel cameras.
Wow.
We put in the NVIDIA Orin at that time to really bump up the compute to get 400 sparse tops, a computer for our second gen autonomy computer with a lot more oomph than we had before. And when we launched that, in the get-go, we didn't have universal hands-free. We had sort of what we called our highway assist feature, but with time, our autonomy features have been improving on that same old hardware platform, right? And that's a great example of software-defined vehicles. And our autonomy features are designed to go further and further. So we're expecting to have what we call point to point over time, where basically you can go from first initially starting from highway to highway. We're going to have parking assist. We're going to have a lot of features, and you can actually go to a website and you'll see, under Autonomy Plus, the features that come out in 2026. So over time, it's really a continuum. And if you think about it, the continuum started with very simple features before, like blind spot warning, lane departure, and all of that. But that continuum has evolved a lot. And today we're at the point where we can do hands-free driving. We'll get to the point shortly later, we'll do point to point. And then the final sort of the crowning piece will be when we do L4, which is
Mhm.
our, the goal we plan to do with Uber, Right.
So just to go over this again really quickly, Vidya, what can the universal hands-free system do right now? Because I think that's very powerful and it's worth
It
covering
is
again.
extremely powerful. And what I can tell you is I actually picked up my R2 from our factory normal about a little over a couple weeks ago, and I drove it down to California, primarily on Highway 80 and a few.
Hmm.
And what it can do is you take you don't have to have your hands on the wheels. You engage that feature, and it can stay in lane. It can steer and brake as appropriate. And I obviously did most of this on highway driving, where there are no traffic lights or anything of that sort, but it can keep driving. And obviously, occasionally there will be disengagements because it's not a L4 system as yet. But it can really drive anywhere where there's painted lines or, dotted lines. It can drive, right? And that's the main thing.
So it's not like Super Cruise or BlueCruise, where those are sort of geo-fenced to limited access divided highways. This is
No, that's
much
right.
more.
And that's very powerful. I think
Yeah.
when we used to be geofence, we released that when we released our UHF feature, we just opened up many, 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 many more miles of roads, right?
Yeah.
And so I think that's very key. And I did most of my driving heading here on UHF, it really took the monotony out of it.
Because that's a long drive.
It is. And the good thing about it is we see over time, we're going to add more and more. We'll add traffic lights, we'll add, stop signs, we'll add more things. And that's, as I talked about, it's the continuum where once as you keep solving problems, it gets better and then it gets closer and closer to that L4 goal.
So one more related one on the vertical integration front, your CEO, RJ Scaringe, just earlier this week as we're recording, talked about LiDAR. You showed LiDAR on the R2 in December. That's coming towards the end of this year, early next year. And you talked about having that also developed in-house. Can you talk a little bit about that? Are you going to do that entirely in-house or partner with an existing LiDAR supplier? Or
Yes. So I actually believe that those remarks might have been taken out of context. We are not talking about developing LiDAR in-house. At least we don't have any plans as of now to build LiDAR in-house. I believe RJ was talking in the context of developing LiDAR in competencies across
the perception capabilities, LiDAR perception and so on.
No, just LiDAR itself, but being able to broaden the availability and the manufacturability. And I think that's he was alluding to, but I think it was taken out of context. We are not, we're not announcing any in-house LiDAR plans.
Okay. Thanks for clearing that up.
There's been a misinterpretation, or I'm not sure what happened there, but yeah, there were to correct the record. We are not building in-house LiDAR within Rivian.
Could be part of the vertical integration. Might want to think about it
someday. But we're definitely not something we're announcing today. Who knows?
Right.
But yes, I think that's who can predict what happens down the road, but definitely nothing in plan right now.
With vehicles getting more and more electronic features, is there a risk of things becoming unserviceable? And maybe the zonal electrical architecture improves reliability and serviceability, but is there a point in 10 or 15 or 20 years where maybe you won't be able to get parts for a Rivian?
So I think there is twofold. When we design for any electronics for a vehicle, we design with a minimum, 10 plus year lifetime. We have service agreements with our suppliers, where they commit to giving us service parts for long, over 10 years. So that's all locked in. We also have an inventory of service parts that we keep, and we look at service really looks at how often we're replacing things. So that is all part of the methodology when you design for automotive, is designing for service over time. And you rightly said with sort of the zonal approach, you have fewer components really. If you look at it, the number of ECUs, so the fewer components, fewer wires means less likelihood of failure. So I think that also there are competing competing vectors here, and obviously I think electronics is a challenging space as fabs decommit to older technologies over time as they're trying to move. So it's a balance, but you plan for it. Right? So I think you get some wins, And you get some wins with a sort of clean sheet of paper technology methodology where you have fewer ECUs, fewer wires, less chance of failure. You also design in vehicles really for especially things that are important. There's functional safety baked in. So you design for fault tolerance of some kind. So all of that goes in favor. And then, definitely lifetime is a challenge, but, you bank service inventory. That's something you have to do.
Mm-hmm. Fascinating.
Is there also the potential for, at some point in the future, if service parts are not available anymore, to perhaps do upgrades, to upgrade to a newer generation of electronics in an older vehicle?
Right. And I think it's on a case by case basis where possible. That could be an option too. And I think, but I think by definition for us, no vehicle is designed without allowing for service parts. So we just have to allow for service parts availability over time. I think that's the requirement.
Yeah.
Lately, we've been seeing, there's a lot of dynamism ever since COVID, there was a lot of the semiconductor shortages. We have redesigned parts sometimes because of that reason. So a service part is going to become hard to get because some certain memory, and we're seeing that now. Right now, there's a lot of pressure on the memory market because of data centers. So we are redesigning certain boards that actually service parts in order to keep their lifetime, right? So that vertical integration approach allows us to be able to do that.
Okay. And I think one of the last questions I have has to do with, with all of these things that you're developing in-house. You've already got a joint venture partnership with Volkswagen, who I guess now is Rivian's biggest shareholder. And through that joint venture, you're sharing a lot of the electronic architecture that Rivian has developed, the software platform. Those are going to start appearing on VW Group vehicles, I think sometime in 2027. These newer things that you've announced, things like your in-house chips and other developments are, or your autonomy system. Are those features things that you are likely to license to Volkswagen or to other potential partners in the future, or are some of those things you want to keep to yourself to try and have a competitive advantage?
Great question, Sam.
That's a very good question. I think as we've shown in the past, we're open to licensing our technology. So I don't think that we have a hard and fast rule on what, we will and what we will not. I think we assess every situation on a case by case basis. So if it makes sense, we would probably consider it. But as of now, our chip and the autonomy system are restricted to Rivian only.
All right. Thank you.
But if the situation is right and the business is right, we'd be open to it, I suppose.
Could be a whole new segment of the business for you guys, and probably one that's very profitable.
That'd be great.
Yeah.
We'll take.
Right. But Vidya, fascinating discussion here, all about the ins and outs of the Rivian products and the electrical side of those vehicles. It's a world. I'm not a trained engineer. I can't do math. I can barely balance my checking account. But it's a fascinating glimpse for me as an outsider into what actually goes on when you guys are developing these cutting edge new vehicles. But before we cut you loose here from the show, we like to do a little segment. It's called 3 for the Road. And basically, we each answer a quick question to sort of help drivers go green. And given your role at Rivian, we thought it might be interesting to go with sort of a tech-themed question. So I throw this to you. What is your favorite advanced driver assistance feature, if you can pick just one?
Today, if you ask me, just because I just came off this long drive from Normal to Palo Alto, California, I would pick our universal hands-free feature. It was a lifesaver. I did the drive. I didn't feel a thing. And that confidence I had was just phenomenal. So I would say yes, universal hands-free or UHF.
I figured you'd pick that one based on your comments earlier. But Sam, what do you got?
For me, I would say something like cross-traffic alert. Blind spot monitoring has been a real boon over the last 10, 15 years. And the expansion of that functionality with the corner radar sensors to add cross-traffic alert, because it's often so difficult to see what's coming, now that everybody's driving SUVs and trucks, when you're trying to back out of a parking space, or even, moving out, having cross traffic alert on the rear and increasingly on the front end of vehicles to let you know when there's somebody coming from the side that you might not actually be able to see yet. I think that's a really handy safety feature.
Absolutely. I love a good hands-free driving aid. They're a godsend on long trips. But my pick for this is a little bit more mundane. I went with automatic high beams because I also love just having the headlights switch on. They flick up when nobody's coming. They dip automatically when traffic is there. I think it adds greatly to safety, and the next car I own will definitely have that because the one I've got now does not. So automatic high beams.
To add to that, I will say that on the second generation R1, the adaptive headlights on there, when you're driving on a rural road, and there's nobody around, and then when suddenly a car comes into view, the way that adjusts the light pattern and still maintains the high beams in areas that's not going to blind the oncoming driver, while dimming it in a specific zone. I think that is such an amazing feature, and more vehicles should have that type of capability.
Yeah.
Actually, I love what you both shared because that's a good example of it's never too much technology and it's intuitive. You didn't have to do anything to activate it, and it just smartly did it at the right time, right? And I think that's the kind of technology you want in a vehicle.
I agree totally.
Absolutely. But Vidya Rajagopalan, Senior Vice President of Electrical Hardware at Rivian, thanks so much for joining us today. Fascinating discussion here.
Thank you. My pleasure. Thank you for having me.
Well, that was a great discussion, Sam. And what did we learn today?
I think we learned a lot, especially about why Rivian is doing some of the things they're doing in terms of vertical integration, doing a lot more stuff in-house than we have traditionally seen in legacy automakers, like designing their own chips, and a lot of what they're doing around developing automated driving capabilities for their vehicles. So, and then also, what are the benefits of what they're doing with their electronic architecture, going from a domain architecture to a zonal architecture? Why is that? What helps? What does that improve on the vehicle? So there's a lot of interesting technical stuff in there. This was a good one for the geeks.
Yeah, absolutely. But very practically, it was fascinating to hear how much wiring they could take out of a vehicle switching to a zonal architecture from a more traditional design. And also, of course, the weight. What was it? Something like 44 pounds of
44
copper?
pounds, yeah. When they first did the changeover from the first to second generation R1 a couple of years ago, they did an event at their Plymouth, Michigan Tech Center, and they had a bench set up with all the domain controllers from their old system and the zonal controllers for the new system, and then they had a big ball, a ball of copper wire about this size, it was 44-pound ball of copper wire. That this is all the wiring we took out of the car. And if you've ever looked at a car wiring harness, and if you open it up, usually it's wrapped up. If you unwrap it, you'll see there's big bundles of many wires in there, and they eliminated a lot of that by not having to go to all these individual electronic control units.
With a zonal architecture, just for clarification, is there one central controller for everything, or are there maybe two? I can't remember what she said. Maybe one at each end of the vehicle?
Yeah, it depends. It varies. Everyone is a little bit different. So on the, I'm not sure exactly the specifics on the R2 yet. I haven't seen that. But on the R1, for example, there's two central compute units. There's one that controls all the driver assist and chassis control stuff. There's another one for the infotainment system, and then you've got five zone controllers and the battery management system. Prior to that, there were 17 controllers.
Big reduction.
So they pretty dramatically reduced that down.
Yeah. So I mean, regardless, even if you just had two or three, it's still a huge reduction in the overall complexity.
Yeah, it makes it a lot easier to assemble the vehicle. You've got a lot less wiring. I remember, a company I was working with some years ago, doing some research with. They were telling us, they made wiring harnesses among other things, and they were telling us about a wiring harness for a Mercedes S-Class.
Oh gosh, I
And
can't even imagine.
each one for each vehicle was shipped in its own separate crate, and this wiring harness was so big and so bulky that what they actually had to do is, once they took it out of the crate, they would put it on a conveyor and actually send it through an oven to warm it up to make it pliable enough
To get
to
it in the
manipulate it
vehicle.
into
Yeah.
the body of the car. And it took 9 people to get the wiring harness into the car. So that's no longer an issue.
Yeah, I would hope not. That's insanity. They
Yeah,
have to
it
heat
is.
it up in order to even install it. And then if you're not fast enough, you might get stuck halfway. Then what do you do then?
Yeah. You got to work quick.
Right? You gotta practice. And then you had a great question about the licensing of the technology, because their stuff works very well, and be interesting to see if that migrates to other OEMs in the industry. So
Yeah, so I mean, they are already sharing some of their technology. Their that zonal architecture, at least the version of it that's in the R1, in the second generation R1, and their software platform. Those are now part of a joint venture that they set up with Volkswagen, and VW is going to start using those in some of their VW Group vehicles, including the Scout. We talked with Ryan Decker recently. The Scout is going to use the Rivian electronic architecture and the software platform at its core, but they're also going to be using it in about I think they said roughly about 30 different Volkswagen Group vehicles by 2030. But the newer technologies that they've announced, that custom chip and the automated driving system, that they haven't decided yet on whether they're going to license that to other manufacturers.
because that could be their standout feature that really drives sales potentially.
It could, but licensing it, could also help them offset the cost of development of those technologies. So they need to look at it on a case-by-case basis. If there's a demand for it, my guess is at least the chip is something that they will probably license. If there's companies that want to use it, because that generates some more revenue for them and helps offset the cost of designing those chips.
Yeah. Well, Sam Abuelsamid, always great to see you and learn what insights you've got.
And it's always great to talk to you, Craig. And it was a great conversation today with Vidya. I really enjoyed that, learning a little bit more about what they're doing at Rivian.
Absolutely. And with that, thank you all so much for watching GreenCars, the podcast, right here on YouTube. The audio version of this show is available from your favorite podcast providers. But next, make sure you click the link on screen right now to check out another great GreenCars video, and make sure you subscribe while you're at it.